The surface is calm, no waves, no fire, no warning. But deep below, gas is building. And when the lake finally breathes, everything around it stops. Nature looks calm, beautiful, silent, alive. But beneath that surface, there is force, pressure building, gas rising, ice cracking, wind sharpening. A lake can suffocate a valley. A tree can burn your skin. A storm can erase direction. This is Nature is Scary, the planet that does not care. A lake looks passive, flat, still, contained. But still water can hide motion you cannot see. Layers of temperature, layers of chemistry, layers of gas. From the shore, it looks finished, a quiet surface, a sealed mirror. But beneath that surface, water keeps sorting itself. Cold below, warm above, salt here, oxygen there, and sometimes almost none at all. A lake can hold carbon dioxide in its depth. It can hold toxins at the surface. It can trap ancient water under ice. It can preserve a body or kill without a wave. That is what makes these places dangerous. They do not always announce themselves. They do not need a storm. They do not need visible violence. Sometimes the chemistry is the event. Sometimes the waiting is the event. And in one lake in Cameroon, it was the waiting that made the disaster possible. In August 1986, Lake Nyos did something that sounded impossible. It released a cloud of carbon dioxide so dense, it rolled downhill like an invisible flood. No flames, no lava, no visible poison. People woke up unable to breathe. Others never woke up at all. Villages around the lake fell silent. More than 1,000 people died. Thousands of animals died with them. The gas did not need to attack. It only had to replace the air. Carbon dioxide is heavier than the mixture we breathe, so when it spilled out, it hugged the ground. It moved through low places, into homes, across roads, through fields. Lake Monoun had given a warning 2 years earlier, but Nyos revealed the full scale of the danger. A lake had become a suffocating machine, not because the water rose, because the gas did. To understand why that happened, you have to look beneath the surface, where pressure turns a lake into a sealed chamber. Lake Nyos was not a normal surface disaster. It was a pressure disaster. Deep below the lake, carbon dioxide from volcanic activity had dissolved into the water. At depth, pressure kept the gas trapped. Year after year, the lake stored more. A quiet accumulation, invisible, stable, until it wasn't. If something disturbs that deep water, a landslide, a cooling event, a sudden overturn, the pressure changes. And once the gas begins to come out of solution, it can trigger more release, and then more, and then more. The effect is like opening a shaken bottle, but on a lethal scale. This is called a limnic eruption, a lake releasing dissolved gas in a sudden burst. After Nyos, engineers installed degassing pipes, a controlled way to let the lake breathe slowly instead of all at once. But suffocation is only one thing strange water can do. In other lakes, chemistry does not erase the dead. In northern Tanzania, Lake Natron looks unreal. Red, orange, reflective, almost beautiful enough to seem harmless. It is not harmless. A liquid that burns. The water can become extremely alkaline. loaded with salts and minerals, hot in places, caustic enough to burn skin and eyes. Most animals avoid it. Some do not survive contact. And when bodies are exposed along its margins, mineral-rich conditions can dry them, coat them, and leave them looking preserved. Not turned to stone by magic, not frozen in time by myth, preserved by chemistry, water acting like a mineral bath, then a drying agent, then a record. Yet, even here, life adapts. Lesser flamingos breed around the lake, using conditions that keep many predators away. That contradiction matters. The same chemistry that protects one form of life can destroy another. And sometimes the warning arrives as color. Some lakes advertise their chemistry openly. Pink water, blood-red shorelines, colors that look artificial but are completely real. In many cases, the color comes from hypersalinity, salt-loving algae, bacteria, and archaea producing pigments under extreme conditions. Dunaliella can load the water with orange and pink tones. Microbes can push it deeper, redder, stranger. Elsewhere, iron-rich water or suspended minerals can stain a lake crimson. What looks like a warning sign is often a chemical signature. Not every pink or red lake is deadly, but these colors usually mean the environment is far from ordinary. High salinity, high stress, low oxygen, biology surviving at the edge of tolerance. The beauty is real, so is the message. A lake can look vivid because life is adapting to conditions that would shut most life out. And sometimes the danger is not in the color, it is in the bloom spreading across the top. Not all dangerous lakes are remote. Some are familiar, warm, shallow, popular. Then, slowly, the surface changes. A green film, a blue-green sheen, thick mats gathering at the edge. Harmful algal blooms, often driven by cyanobacteria, can release toxins into the water. Some attack the liver. Some attack the nervous system. Some make the air itself irritating near the shore. Pets collapse after swimming. Fish die in clusters. Beaches close. Drinking water becomes a problem. And even when toxins are not the immediate killer, blooms can drain oxygen from the water as they decay, turning whole sections of a lake into suffocating zones for aquatic life. The same calm surface that looks inviting can become a chemical warning. But the strangest lakes are not always the most visible ones. Some have been hidden from the atmosphere for longer than human civilization has existed. Some lakes are dangerous because they change. Others are dangerous because they have not. Beneath Antarctic ice, subglacial lakes have been sealed away in darkness for immense spans of time. Lake Vostok is the most famous, buried under kilometers of ice, cut off from wind, cut off from sunlight, pressurized, ancient. These lakes are not killing landscapes the way Nyos did, but they reveal another kind of threat. Water can preserve a separate chemistry for ages, a separate microbial story, a separate environment waiting intact beneath the surface world. That makes them scientifically valuable. It also makes them unsettling because they remind us that lakes are not always open systems. Some are sealed chambers, archives, pressure vessels, time capsules. And once you understand that, a calm lake stops looking simple. It becomes a container, sometimes of gas, sometimes of toxins, sometimes of life that has been waiting in the dark. We are taught to fear motion, floods, waves, storm surge, water that arrives fast. But some of the most dangerous lakes do almost nothing at all. They wait. They store carbon dioxide until the air itself becomes unbreathable. They concentrate alkali until contact becomes corrosive. They support blooms that poison a shoreline. They trap ancient chemistry beneath ice. They preserve bodies instead of erasing them. The danger is not always impact. Sometimes it is condition. A set of physical and chemical rules holding steady, quietly, until something crosses the line. That is why lakes can feel deceptive. The surface tells you almost nothing. Calm is not safety. Stillness is not emptiness. A lake can suffocate, preserve, poison, transform, and that makes it something more than scenery. It is a system, one that does not need to move to kill. And once you understand that, water is never only water again. Some of the deadliest places on Earth look completely calm. Invisible gases can settle into caves, valleys, and villages. The air can change without warning, and one breath can become enough to overwhelm the body. What we have seen is not nature turning evil, it is nature operating normally. Gas rises, water moves, storms form, and when the conditions align, life gets caught in the system. Because the planet does not choose victims, it only follows physics.